Hello guys, in this video we are going to build this 3D printer. For those who do not know what a 3D printer is, so it is a device which can build 3D objects by uh, adding material on top of it in succession. So this particular machine is a FDM printer. FDM stands for Fused Deposition Modeling. What it does is it uses a plastic wire which is called a filament and melts it and then deposits in succession in layers. So before you go ahead and say this printer I have bought from market, so yes, I originally did, but I had a problem with this. So as you can see that it is broken into pieces and the plastic parts are kind of rotten and they keep breaking by just uh, giving them a slight push or a slight grip. So I think the parts are destroyed by uh, moisture or something. So most of the parts are broken. As you can see, I have removed the hardware from those. So a few parts, one or two, survived, like this particular one. This is the extruder, the main part that melts the material and deposits it. Apart from this, all other parts are gone. So I have taken out the hardware. As you can see, this screen housing is also surviving, so we can use this still. And so these are the rods, the heated bed and everything. I have taken it out, and so we will build these parts and rebuild this printer. The frame, as you can see, is intact, so we will use it as it is, and the electronics are fine. The main thing that is broken is the motor holdings, brackets, and some other plastic parts. So for building the parts we are using this 10 mm thick aluminum plate. As you can see, it is quite difficult to work with such a thick plate while you are cutting something precise. So I have built a fixture, or you can say device, to cut this plate which I am working on right now. It cuts quite cleanly, if you can see. So I built this particularly for building those 3D printer parts, and if you want to know more about this particular project, I have uploaded a video on my YouTube. You can go check it out. uh, so this part which I am building right now, one of those I have already built, you can see on top, and one I am working on is under the first one. So this will be holding the two z-axis motors. This will hold the motor, and the hole that you see in the middle is for holding the rod. And we are going to build mirror replicas of this one. So I have cut some straight lines, and then we will just finalize it. So you might be thinking that how am I going to cut that part away, the middle part? So I am going to cut diagonally and then progressively cut in opposite direction, and then small pieces I will keep removing using the saw. So this is the final part that we are going to use. In the left one you can see I have done some additional work. I have added a wedge on the top. A part is cut out. On the left side there is a screw which I have added to tighten the rod in place. So the left side part is complete. The right one is still work in progress. These are going to be mirror images of each other, and so the z-axis motors will be held down. We have two z-axis motors for this particular printer. All the other axes are working on a single motor, so we have built two of these to hold the two motors and two rods. These are the brackets I have shown you were for the motor, which will be on the lower end of the printer, and to hold the rod on the top end we will need another two brackets. So these two are going to be those brackets. I am going to add holes on the base to tighten it to the frame, and then a hole in center top side to hold the rod, and then cut in between and add screws to tighten the rod. After that we are going to work on the y-axis. So previously I had the bearing that you are seeing exactly like this one, and it was holding using plastic parts which are now broken. So I have bought these bearings which have a housing inbuilt, which is also made of aluminum. The holes are already threaded, so it will be quite firm and accurate once it is built. So I am going to add three bearings. So there were two bearings previously on that side and one in this side, but the sizes of holes are different, so I am going to uh, flip the sides. I am going to use two bearings on this side and one on the other side. So as you can see, this is already threaded, so I'm going to use two, one here and another one here, and then I'm going to use one bearing on the other side. Bearings are in place, and you can see that's how rods will pass through them. Rods are easily sliding, so the two bearings are aligned perfectly. There is no resistance. The single one is already good to go, and so the carriage of y-axis is ready. We have to bolt it to the frame now, and attach the belt and motor that's also remaining. Let's move ahead, and this particular part that you see is there to hold the y-axis motor. It will be bolted down on the two sides to the frame. You can see the two holes, so I will bolt it down to the frame, and then this will power the belt which pulls the y-axis carriage. And as you can see, the electronics are exactly in part where they should be. These are the end switches that you see on the table. So the y-axis is in place. I have added these uh, sketchy looking brackets on all the four ends in the two rods, and the carriage is working, but there is a slight issue that I will show you in a while. So you see that the carriage is stuck. It is interfering with these brackets as the gap is a bit too low. uh, it is interfering on both of these ends and on the farther end too, as you can see. On that side it is actually interfering with the bolts itself, so I have to add some kind of clearance, and for that I have decided to add two additional nuts on the lower side. So this black part, the black plastic part that you see, is lifted by approximately 5 mm, which will give us enough clearance to make this work. And I have added those nuts. If you see, those are in place, and yeah, this should be enough for our goal, and it should now move clearly past the brackets, and it does. The bearing is now touching the bracket, so that is the maximum distance that this particular axis can travel, and which is fine, which is more than what we need and what this printer originally offered. So the y-axis carriage is working now. I have also added the motors for z-axis. As you can see, those are the two motors that I was talking about, and the rod is in place as well. On the top side we have also added the brackets, and that's how our z-axis is going to look. So on the z-axis we mount the x-axis carriage and x-axis itself. So As also you can see, there are flexible couplings which helps to drive the lead screws. So in the x-axis there will be three parts. This particular one is holding the motor, then there will be another which will be another end, and one will be the x-axis carriage. So I have cut a u-shaped metal piece. This particular part I am showing it will be the carriage on the x-axis. As you can see, I have added 8 holes which are countersunk, plain and flush on this side, but these are countersunk on the other side. The reason for making them like this is we are going to add some allen bolts on this side, and I want the surface should still be usable for some other work, basically to adding extruder. And to make these countersunk is the bolt itself goes down and the surface is still plain, and we can add our extruder here. I will show in a bit what I am talking about. So this is the carriage, main carriage. The extruder will be mounted on top of this. So what we will do is we will put the extruder like this. If the bolts were stuck above the surface, then those will create some problems for us, and we will not be able to mount this on top of the aluminum part. But as this is countersunk, we can add the bearings on the lower side of that part, and the top will be used for mounting the extruder. So we have added the bearings and tightened them. The carriage for x-axis is ready. It slides smoothly, as you can see. Now let's add the motor and extruder, so we can see if this works as we wanted. So I have to do some extra work to tighten the bolt from both of the sides, as one side covers the bolts of other side. So I have to make some improvements and improvisations, but yes, this works now. We can add the extruder and make it work. The extruder is now mounted, and I will show you. Well, it slides smoothly. We also have to add the third x-axis part, which will slide onto the second z-axis smooth rod, which will be added on the far left side from the viewer's perspective. Now it is added. As you can see, I have added one bearing on the left side for z-axis rod, and the x-axis carriage is ready. So now it slides smoothly on the z-axis. As you can see, I am moving it right now with my single finger. So some weight is there, but it moves smoothly. It can go all the way to the top, and that's what we want. So this particular z-axis will be moving with the help of lead screws, which I will add later. The two screws you see right now will be added, will be used to tighten the x-axis belt. So to carry the whole x-axis onto z direction, we will be using these aluminum parts with these lead screw, flange nuts. So we will tighten these aluminum parts onto our z-axis, the x-axis ends like this, and the lead screws are screwed in to the flange nuts, and one side into our flexible couplings. So all the three axes are now in place. The y-axis moves along with the belt. The x-axis still remains without belt, but the carriage and the motor and the idler pulley are in place. Z-axis still moves I am moving it with my hands, but yes, this can move now. So this is taking its final form now, and the axes are now in place. So this is how it looks from the front. X-axis carries, the y-axis carries, and the whole z-axis which carry the x-axis gantry is now tightened into place. Now we will move on to adding the extruder and wiring up the electronics, and then we will see if everything works as it should. The brackets are all in place. Okay, so now I have added the extruder, and I have lighted it up, so we see some numbers on the screen. Let's see if the axes are moving. So first we will start with the x-axis, then y, then we will see about z or z-axis. So x-axis is moving in both the directions. So I had to do another calibration to make uh, the calibration of movement and command that we are giving. For example, if I am asking it to move 10 mm, it should be moving 10 mm, not 11 or 9 mm. So I had to do that. The x-axis travel is reduced a bit, so I had to do that too. Now it moves around 160 170 mm. Previously it was moving 200 mm. Z-axis is also moving. You can see the two lead screws rotating. The gantry goes up and down. So axis movement is working. So let's uh, do some final work. I have added the end switches too. So these switches are basically for safety purpose. Let's say when you turn on the printer does not know where the axis is, where each axis position is. So it basically have to come to 0 in all three axes, which is called home. So when you home a 3D printer, it just starts moving all three axes into negative side position, and if your printer doesn't know where it should stop, it will keep moving and it will break the belt or some parts. So these switches tell it to stop moving and to mark 0 or home. So as you saw, the x-axis carriage hit the switch and stopped, so did the y, and now the z-axis carriage stopped all the way to the bottom. So there is some gap. I have to do bed leveling, which is a manual part. After that, you can see we started printing this part, or not a part, this is just some decoration. So this is our printer which we were working on. This is now complete, and it is now doing the printing, as you can see. So this is how the interface on the laptop looks. This is what we are using. It is called Fronterface, open source. It gives the command which are in G code to the 3D printer machine. So what we are printing is a skull with a rose on top of its head. I will show you in a bit the completed and final product. Right now it also has the support, so it does not look clear, but so this was what we were printing. So it is as you can see, just a decorative piece, a skull which has a rose in its head, which is grown like a mushroom in its head. So you can see layers here. So the quality of the print was not top notch, but yes, for the beginning it is quite okay. The printer is working. We can do some fine tuning later, and after the fine tuning I printed a few more parts, and this is one of the projects which is printed in multiple parts. So basically there are more than 20 parts for this one, and the quality is now very much improved. In this part you can see it is very clean. And you must have seen this part somewhere on the Instagram or on the reels. This basically, if we rotate the key and leave it start dancing by moving its skull. So thank you very much guys for watching this video. If you like it, please leave a comment and do subscribe us for more such content.